And so that's why I say, like, when the aliens arrive, I kind of hope that they don't do physics the way we do, because we've learned so much about the choices we've made and what it is to be human in the universe. And in the end, like, what's philosophy about, right? It's that. It's about what is it like to be human and why is it like that?
So welcome everyone to today's interview, where I'm very pleased to welcome Professor Daniel Whiteson. He is an experimental particle physicist and professor of physics and astronomy at the University of California, Irvine. His work focuses on the analysis of high-energy particle collisions. He also co-hosts a podcast about the universe that's called Daniel and Kelly's Extraordinary Universe. He's co-written 3 popular science books and co-created an educational preschool television series on PBS. His new book is called Do Aliens Speak Physics? And Other Questions About Science. There it is. And the Nature of Reality. And it also has illustrations by Andy Warner. And this is the book that's going to be our focus for today. But yeah, feel free to add anything. But with that, welcome. And thanks so much for being here, Professor Whiteson.
Yeah, thanks very much. Really a pleasure to be here. And I'd like to add that I'm not formally trained in philosophy at all, but I'm one of the maybe minority of physicists who think that philosophy is really important and fascinating. I mean, for me, the reason that questions in physics are interesting and have power is because of their philosophical implications. And the reason I'm a particle physicist is because I think those questions are the most philosophically interesting. You know, like, what is the fundamental nature of the universe? So excited to dig into all that with you.
Yeah, no, that's a good point. And before getting into some of the questions I already had planned, it really does feel like this is one of those areas where philosophical questions and, of course, the scientific questions can sort of work together to approach these questions. We have to think about, like, what is language, or what sort of things might there be that could communicate in different ways. What is the nature of physics and mathematics and so on? And so some of these questions are quite philosophical as well as scientific. So yeah, so maybe just to start as a bit of an overview, like, what is this book about? Maybe just introduce it a little bit. What might people expect to get from it?
Yeah, this book is essentially asking, is physics as we described it and understand it, is that really something that's universal, in the sense that, is it part of the universe, or is it part of our understanding of the universe? Is it part of the way our brains work? How much humanity is there in our physics? And, you know, framed that way, it's really a philosophical question. But if you talk to people in the physics community, they all think, well, obviously physics is universal. That's the reason we got into it, you know? Questions about biology or psychology or economics, those are obviously limited to what happens here on Earth. But the great power of physics is that we can describe things happening in our galaxy and in other galaxies. But they make also this second leap. Not only do they assume that physics can describe phenomena in other galaxies, which is something we can test, right? We can see other galaxies through the telescope. We can tell the same rules of physics seem to be applied or not, and we need to update those laws. But the second leap is to assume that everywhere around the galaxy or in other galaxies, other creatures would describe physics the same way. You know, not necessarily with our symbols and our, you know, the details that are of course cultural, but fundamentally that the description is the same. And, you know, physicists assume that when the aliens arrive, you know, linguists will take a little bit of time to figure out the squiggles or the sense or whatever, but that eventually we're going to be at the chalkboard talking about Lagrangians, because they will clearly be doing quantum field theory or string theory or whatever, because the physics that we have uncovered is the reality of the universe. And the reason I wrote this book is that I wasn't so sure about that. And I wanted to try to make the strongest argument on the other side. How is it possible that there is humanity in our physics? Where in our physics could humanity have crept in? Obviously, the best way to know that is to meet aliens, and we're waiting for them to show up. But without that, the book essentially asks, what can we do to identify places where humanity might be part of our physics, where we might differ from the aliens? And are those in the little details, or are those fundamental and at the foundation of the whole project?
Yeah, great. And before getting to some of the details a bit further there, I just want to mention, of course, Andy Warner contributed a lot of illustrations to this book, and I really thought they were great and really add to humor and enjoyment of the book. The book is also,
and not just the illustrations.
Yeah, the book itself.
Andy is a smart guy, and he knows a lot about the history of science. And the reason I reached out to him, I cold emailed him about doing a book about aliens. And the reason I did is not just because I love his illustration style, but because he knows a lot about science and history, and he added a lot to this book, not just the awesome drawings of aliens.
Yeah, great. I was going to ask, how did that sort of collaboration come about? But he sounds like he's just asked him. And I
want to encourage people to just cold email folks whose stuff you like and you want to work with. That's how I ended up working with the other cartoonist I've written with, Jorge Cham. I just cold emailed him, and cold emails work sometimes.
Yeah, for sure. So getting into some of the content here, then one of the key tools that you use to frame the discussion is what you call extended Drake equation. And so for listeners who might be unfamiliar, the Drake equation it's an equation for estimating the number of intelligent alien civilizations in the galaxy based on various parameters. I don't know if we need to get into that here, but you have an extended version of this, which aims at sort of filtering it down further to estimate how many would be sort of likely to have meaningful scientific exchange with us on certain scientific questions. So maybe can you introduce us a bit further and expand on this general approach?
Yeah, I wanted to extend the Drake equation because the structure of it is really useful. I mean, the structure is also really simple. It just takes all these parameters and multiplies them. What fraction of planets have life? What fraction of that life is civilized, et cetera, et cetera. But that's really the approach we need because we're starting from a big number, all these solar systems that are out there, and then we're asking what fraction of them have all of the elements needed in order to have that productive scientific conversation. My goal is aliens show up and we are talking about science. We are figuring out, we are learning from them everything they've understood after 1 billion years of scientific investigation. That's the fantasy. So what do you need in order for that to happen? It turns out you need quite a few things, and you need all of them, which is why we use the structure of the Drake equation. Number one, you need them to be scientific. Right? You need them to be interested in questions of why, how does the universe work, not just technological. And we can dig into in a minute how the separation there. You also, not only do they have to be scientific, but you have to be able to make some sort of mental connection with them. You have to be able to find some translation from our thought patterns to theirs. And that's not trivial, right? And on top of that, you need to be interested in the same kinds of questions, right? Maybe they look at the universe differently and they're curious about different stuff. And so we're not going to have a lot to talk about at the first interstellar science conversation, and then finally, the last piece is whether or not we share the same answers. It's possible that they're working on an alternative version of physics, that there are multiple explanations for the universe. Or it's possible they have an answer, but we just can't understand it because we're not smart enough. So I like the structure of the Drake equation because it emphasizes that all these things have to be in place. If you are missing one of them, it doesn't matter if they're interested in the same questions and have fantastic answers if we can't communicate with them. You need all of these in place. If any of the factors are zero, the whole thing is zero. That's the beauty of the simplicity of the structure of the Drake equation. So I broke it into those 4 pieces. Do they do science? Can we communicate? Do they ask the same questions? And would we find or understand the same answers?
Right. Yeah. And as you mentioned there, one of them, and you sort of briefly hinted at this distinction here between, doing science and being, say, technologically advanced. It's entirely possible to advance technology well beyond scientific understanding. And you imagine these navigators that do just that. I mean, maybe you can talk a bit more about this, but for me, thinking about this, while that's of course possible, it seems sort of not very likely that highly technologically advanced civilization, maybe one capable of interstellar travel or at least communication, that wouldn't have at least decent theoretical development. I mean, so I don't know. What do you think about this?
Yeah, that's a fair point. Yeah. I mean, the argument I make in the chapter is essentially what you said, that you don't have to be scientific to be technological. And, in the history of life on Earth or humanity on Earth, we've been technological long before we were scientific, right? We were like fermenting milk into yogurt, and we didn't know how that happened. We had no idea the microbiology. We're making swords, all sorts of stuff we were building technology without understanding it at all the way back to, stone tools 1,000,000 years ago. So technology definitely predates science, and therefore science is not necessary for technology. And, in the book, to make these things more concrete, I provide a bunch of little fictional stories, also because I'm an aspiring science fiction author, as are most physicists. And so I liked writing these little fictional descriptions of how this could actually work. But you ask, is it likely? And of course, doing science makes it much more powerful to develop technology and much more rapid. And so, if you scan across all of the civilizations that are capable of traveling across the galaxy to reach us, it does seem unlikely that the ones that reach us are the ones that have no understanding of how they did it, that they're technological without being scientific. But I think actually more likely is the opposite. I think that we tend to view, at least physicists do, or amateur philosophers tend to view science as a sort of fixed thing. Like, we have discovered science. Now we use science to develop technology. But science is a fluid thing. It's a cultural thing. It's something we're developing, that's evolving, that's changing. The concept of a scientist, somebody who does this for a living, and even the word scientist is only like 100 and something years old. And so it's entirely possible that when aliens show up, they're not doing science as we call it. They're doing something else far more advanced, that they look at our science and they're like, man, y'all are so primitive. There's a much better way to figure out technology. It's, science plus plus or whatever it is. And so I think it's unlikely that when aliens arrive, we will have that in common with them, that our science, the development of our science itself, the process, not the results, but the process will be at the same stage as they will. So I think there'll be a fundamental mismatch there, whether they're much earlier along, which I think I agree with you is unlikely, or they're much further along, which I think is much more likely.
Yeah, that's a good point. I mean, I can even think just think about how much has changed in the way we do science here on Earth in the last few hundred years, and how much it might change in the next few hundred or 3,000 or even millions of years if we're around that long. How much different even then could it be for different sorts of life altogether? I mean, it's, yeah.
And we imagine this scenario where they trot out their physicists and we bring out our physicists and they all nerd out together. But what if they don't have physicists? What if that's not a thing that people dedicate their life to? It's something everybody does, or I don't know how they organize alien sociology. But, just basic questions of who are we talking to among the aliens? There's a lot of cultural assumptions there about how that would go. And, I think physicists are excited to get to the part where they give us the answers in terms we can understand. And so they don't often think in detail about these sort of social or cultural or philosophical stumbling blocks. And so one reason I wanted to write this book is to bring out the fact that philosophers have been thinking about this for a long time. Philosophers of science and historians of science, they know all this stuff. None of this is news to them, right? But I think it hasn't widely percolated because a lot of people, not just physicists, think that it's sort of straightforward when the aliens show up, that obviously physics is something we'll have in common with them, or at least mathematics.
Right. Yeah. You almost want to imagine this scenario where we're creating turns, writing equations on chalkboards or something, but might not go quite like that.
I don't know. I go back and forth. On one hand, that's a fantastic fantasy. For them to tell us, here's how you do quantum gravity, or here's what's inside a black hole, or here's how the universe began. Wow, how satisfying would that be to get those answers? On the other hand, it might be much more interesting if they show up and they're not doing science the way that we do, and they're not interested in that at all. They're doing something completely different, because philosophically that might be more instructive, right? That might be the moment we realize that our science and our physics is cultural in some way we hadn't realized before. Otherwise it's sort of like you travel around the world and all you find is Starbucks, right? That's disappointing. It's not exciting to see the culture is the same everywhere. You want to go around the world and drink weird kinds of hot beverages and all sorts of new stuff. So if the aliens show up, I'm torn between hoping that they do physics exactly the same way we do, that it's like the Starbucks of physics, and between the idea that like they could be so alien it's hard to even understand, and it takes like 300 years of philosophy to figure out like what are they even doing.
Yeah, and then we've sort of been hinting at this other issue already, which is how do we communicate, or would we be able to communicate with them? And yeah, I mean, it could be. I'd like to think about like, well, maybe they don't even speak something that we would even call a language. Maybe their way of conveying information is sort of radically different than we've even thought of. And yeah, I don't know. Maybe can you talk a bit about this? And do you think this would be the communication concern might be a significant filter in the equation here?
I think it's very likely. And I think it's something that we haven't thought about carefully enough. I mean, you could take an actual example of physicists trying to communicate with aliens, which is the Pioneer plaque. So this is, we sent a probe out into outer space, and somebody asked Carl Sagan and Frank Drake, like, hey, would you write a message to potential aliens so we could put it on the plaque? And the story I heard is that they only had a couple of weeks to figure this thing out. So, what they did is awesome. They basically tried to strip away some basic concepts in physics, to take some basic concepts in physics and strip away all of the Earth-based cultural elements, our mathematical symbols, etc. And they've developed like a pictorial description of the hydrogen atom and how the spin flip works, and tried to use that to establish a notion of time. And, their heart was in the right place. They were doing their best to make this obvious. But, I think they didn't recognize how culturally relevant any symbols you choose are. If you're going to communicate with aliens or even with another person, you take the ideas from your head, you got to convert them into symbols, you encode them, and then those got to get decoded into somebody else's brain. There's always that step. And yes, it's silly to like use English because everybody knows aliens wouldn't know that encoding. But even simple pictograms have a lot of culture in how you choose them. They're fundamentally arbitrary, and they only relate to those ideas if you have the cultural context to understand them. Like on the Pioneer plaque is a description of the hydrogen atom using like the Bohr model cartoon. And the Bohr model, the Bohr model is like our understanding of the hydrogen atom for like 20 years in the early 1900s. Like nobody thinks that the hydrogen atom looks like that, right? And before that, they didn't. And so it's like one brief snapshot of a cultural concept of the hydrogen atom we hope aliens will look at and be like, oh yeah, that's hydrogen. I mean, it seems like impossible to imagine that they could understand that. And the fundamental difficulty, I think, is sending something away without having any humans along to explain it. If you just send something out into space, I think there's no chance that when aliens find it, they're going to understand it. Or if we get a message, if SETI ever hears anything, how are we going to know that it's a message from aliens? How are we going to decode it? I think it's impossible. I mean, we should do it, obviously. We should still look, but I think it's impossible. I think the only scenario where it's possible at all is if the aliens are here, or if we're there, and we have a chance to do, what speakers of different languages do, which is like point at stuff and say, this is an apple, this is a donut, this is a mountain, whatever. And then you can associate the symbols with the real things. And from there, maybe you can build up some commonality. But it's not easy, right? If you don't have the people here with you, I think it's very, very challenging. And even if you do, like, it's not that easy to build up that dictionary to get to complex ideas.
Yeah, that's a fair point. I mean, I wonder if there's maybe a little bit of room for optimism. Like, I mean, what if instead of the simple plaque we had sent drive with a significant amount of writing and media and stuff that we'd produced, and maybe images and video and maybe stuff that shows how we, in an environment, learning and using language. I mean, maybe it would still be difficult.
But we did exactly that. The Voyager has the record on it, right? It has like recordings of people talking, and I think a woman laughing, and like brain waves of humans and all sorts of stuff. But how are they going to decode that? They're going to look at those information and know how to translate it into audio or something. It's mind-boggling to imagine how lucky we'd have to be for them to make any sense of it.
Fair enough. I mean, do you think this ways that it could have been done better? Like if we had to do something like that again, where we had to send out something static, I mean, What do you think?
Yeah, no, that's a fair question,
Yeah.
right? Like here I am criticizing what they've done.
Yeah.
What's my idea for doing it better? I don't know. I hate to just throw up my hands and say I think it's hopeless. But, we've sent other messages, like we send a message via Arecibo with this cute pictogram that includes all sorts of interesting information about humanity, sort of in the direction of the wow signal. I think these are all well-intentioned. I don't have a better idea, unfortunately. It's a great question. I wish I had a better idea. I wish the aliens would just show up, because then we could skip all of this stuff. But, people have spent a lot of time trying to figure out and decode languages. And again, because the aliens aren't here, all we can do is think about human languages. And so in the book, I spent a lot of time digging into the past and like thinking about how hard it has been to decode an easier task, right? Which is figure out other human languages without the humans present to explain it to you. And basically it's impossible. Without like cultural clues or cheat sheets like the Rosetta Stone, we've never really cracked an ancient language. And that tells you that it's essentially impossible. Without them around to explain what this means, we're not going to be able to figure it out. But okay, so let's assume the aliens show up and they're here and they can point at stuff and we can point at stuff. Then I think that there's a good chance. There I'm optimistic. I think that there's a really solid chance that we can build up some kind of understanding. Of course, there's still a lot of issues to get through. Like, do they even communicate it? Is it auditory? Is it via scent? Is it via like colors on their skin? Is it something we haven't even imagined yet? And those are fun challenges. But I think, for the purposes of this project, it is possible to get over those. But again, only if the aliens show up, which means in my view, the whole project of like communicating across space and time with aliens, I don't think that's going to get very far, unfortunately.
Right. And it's important to note that if you're communicating with them, they're either pretty close or, it's one message every however many years, because just because of the vastness of space and limits of just light speed, it's just not. Yeah. Nearest star is 4.5 light years away. So
exactly. So even if you're lucky, you send a message and you hear a response in a decade. Right. Like, what kind of conversation is that? Right? It could take 1,000 years to establish hello.
Right. Yeah. I mean, speaking of if they showed up, and of course in the book you really explore a lot of fascinating hypothetical scenarios where you have sort of first contact. What do you have any sort of favorites? First of all, I guess just ones that you find interesting, but I suppose also ones that you find sort of plausible if something like that were to happen.
I mean, I think the most plausible scenario for contact is that we are visited by self-replicating probes from another civilization. I mean, it's not hard to imagine that in the next 100, 200 years, we will develop the technology, the automation, the mining technology, the fabrication technology to build probes which can go out and find resources to build more of themselves. And then because of the power of exponential functions, you can explore the whole galaxy in 100,000 years-ish. And so the galaxy is pretty old, right? It's billions and billions of years old. So the question then is, if a single alien civilization had the same idea and it doesn't take that much technology, then why haven't we been visited? It's like the super version of the Fermi paradox. So I think that's the most likely outcome, not that aliens travel here from a distant planet, because that's hard, but that they use the power of exponential reproduction to fill the galaxy with their probes. And so then the question is like, well, where are all these probes? And, that's a dark place to go.
Yeah. I suppose, you might say something similar, though, just maybe it's just not, especially for advanced civilizations, they're just rare enough that, or recent enough that they probably haven't. It's just not super likely that something would have reached us. Even the furthest stuff from Earth is, well, I guess in terms of light or radio waves, is what, 100 light years away ish. That's really not that far in the scale of even the galaxy. But yeah,
it's certainly possible that they're just too recent, or it could also be possible that they're just not interested. I think we tend to project ourselves onto aliens and imagine that some things are obvious, like that they're going to want to find us because we want to find them. And maybe that's just a part of being human. The same way we, maybe trying to understand the universe is a human thing. Maybe that curiosity is something that's not universal. We just don't know. And so it could be that they're just more alien than we can imagine, which is for some reason keeps them from doing it. Also, maybe they're just more responsible than we are. Like if I could press the button and fill the galaxy with self-replicating probes, even ones that like end up devouring planets and going out of control, I would totally do that because I want to hear about aliens. But maybe aliens are more responsible. Maybe they're like, yeah, that's probably not a good idea. So let's just put that technology on the shelf.
Yeah, or even if they had that sort of technology, maybe it's just much more likely that they use it for expanding locally or gathering resources from other celestial bodies rather than, distant deep space exploration. But yeah, I don't know. I would look to imagine that they would do something like that too, though. But especially if these things could self-replicate. But yeah, cool to think about.
But the other piece of communicating with aliens is thinking about like the language of our science. If our goal is we're going to sit down and have a scientific conversation with aliens, then you can't avoid the question of mathematics, right? Like our science is fundamentally mathematical, and it's been, obviously the philosophical community has confronted this for a long time. Is math something that we've invented or something that we discovered? Is a core part of this. And essentially the book is just an expansion of that, saying to all of physics, or fundamental physics. But that's really at the core of it, because if they don't use mathematics in their science, then it's going to be a difficult conversation to try to understand what they're doing.
Right. Yeah, good. So that's something you discussed in the book. Like, is it more invented or discovered? Maybe how would that issue bear, do you think, on alien science? I mean, is it, if it's more objective and more discovered, does that make it more likely that they would share that commonality in their science if they did it?
Yeah, I think if mathematics is part of the universe, if numbers are real, then it's more likely in that scenario that aliens also use mathematics because it's a part of the universe. It's something they are discovering. It's not part of humanity. But, if mathematics is part of the way that we think, if it's some like useful shorthand or reflective of the workings of our mind and brain, then it's not likely. And then it depends on how similar aliens are to us intellectually. It could be that mathematics is an outgrowth of our evolutionary history, experience being a being with a body that has an edge, and you have an edge to your body, and it's natural for me to think of myself as one and you as something else. And from there, you can think about counting, etc. So it's possible that mathematics and a brain that can comprehend them or think that way comes naturally out of the evolutionary environment, in which case we might have it in common with aliens. On the other hand, it's possible that it's just something that we do, and it comes out of a quirk of our evolutionary history. If you dig into it, these assumptions are not that solid. Like if I want to say, like, okay, I'm clearly a person, I should count myself as one, and integer arithmetic is a very natural thing to come up with. Well, how do I count myself as one? Like, where's the edge of my body, right? Like, is it at my skin? Is it at the tips of my hairs? Does it include the dead skin? Like, there's no crisp definition there. It's just sort of like a fuzzy thing where I say, this is me and that's not me. And it's just a dotted line that I've drawn. And anywhere it's a dotted line that humans have drawn, that they could have drawn differently, that's culture. And that's not something we have to be guaranteed to have in common with aliens. And I started out this project very skeptical. I was like, mathematics obviously is part of the universe. How could you possibly do science without mathematics? And then I read Hartree Field's Science Without Numbers. And like, boom, that book blew my mind. Because it suggests that the whole concept of fields, the whole concept of like putting values into space and time is useful, but it's an intermediate step. It's like, keeping track of your calculations to make it easier to reuse them later. And it's not necessary. And he did this incredible thing where he built a theory of gravity without numbers. He doesn't have fields. I love that his name is Fields and he does science without fields. There's a lot of great puns there. But he thinks about relationships and comparators and structure without putting numbers, without having like a number line. And it makes me think a lot about how I taught my kids math, because you have to introduce this concept. Here's a number line, and we put the numbers on it, and they have this relationship. And when you're teaching a 3-year-old, they have lots of basic questions, and it doesn't seem obvious to them that this is what you do. So it makes me accept a little bit more like, maybe this is something cultural we've come up with over the years that is handy, that makes our science more efficient, at least for us to think about. And we might not have in common with the aliens. It might be that they have a different way of thinking and a different shorthand, and they find ours weird. Maybe theirs is much more powerful. We could even adopt it. That would be awesome. Exomathematics.
A lot of good stuff there that I could touch on. I mean, just to go a step back slightly, when you talked about, say, the boundaries of you and counting one person, I think you had an example in the book of mountains and a mountain range or something like that. Yeah, I think I'm a big fan of some of this vagueness stuff in philosophy. I want to say, it's like, well, sort of two levels here. One, of course, there's some kind of semantic arbitrariness in what we're counting as a person or a mountain and so on. But also, I do think there's some genuine sort of vagueness or indeterminacy regarding which things count as mountain, say, or where the boundary of a mountain is or a person and so on. I'm less convinced that that's suggests some sort of cultural bias or arbitrariness or conventionality to counting or numbers itself, but maybe those things are harder to separate in principle. And maybe we can't really resolve that without looking more narrowly at the foundations of mathematics, but I don't know. Do you have anything to say about that?
Yeah, I wish we had a clearer view of the foundations of mathematics, right? That when we drilled down to it, we understood like what the axioms were and why we had these axioms and which axioms make sense. And we could make an argument for these have to be universal axioms or whatever. But because it's still sort of fuzzy, I think we just sort of look at that and shrug. But I'd love to hear your argument against, integer arithmetic requiring a sense of oneness. To me, it comes naturally out of like counting the objects in your environment. But do you see another way that you could arrive at the idea of integers?
No. I'm fine. I'm fine with that. I think that's right. Probably at least historically how something like that developed. And I wouldn't. Maybe this is human bias, but I wouldn't be too surprised if some other sort of civilization did something kind of similar. They had ways of carving up, maybe very different ways, but ways of carving things up, and then there's something like sortles, and then they could count distinct things under the same sortle or whatever. Maybe it didn't work like that, or they focused on different ways of conceptualizing and carving things up, but I guess that wouldn't be too surprising to me. But yeah, I mean, I don't know. I think that's compatible though with this genuine, sort of convention to the relevant semantics, like what sortles we use and so on. And genuine vagueness or even indeterminacy regarding which things fall under that sortle or what their boundaries are and so on. Maybe there's a little bit of tension there, but I think that could be worked out. But I don't know if we can get into that fully here.
Yeah, I think it really is fascinating. And it's interesting to think about like how the foundation of mathematics in the end is set theory, right? Which is deeply connected to what we're talking about, because it's all about like, well, what do you put in the same set and what don't you? And if I like look at a table of fruit and I say, oh, it's all fruit. And somebody else might say like, no, it's 3 apples and it's 4 pears and it's 2 bananas. Don't put those in the same category, right? And there's a cultural arbitrariness there. And I was surprised to learn that like Japanese people have different feelings about like what gets grouped together in the same set and what doesn't. And so even across like Earth, there's a lot of arbitrariness about how we define what goes in a set. But at the foundation of that, there is still like sets and, which is the foundation of numbers. And like, maybe you don't agree that it should be called 2 apples and you think it should be this apple and that apple, but there's still, units there assumed at the foundation of it. Yeah.
Right. Yeah. And I've talked with people before who think that not only is mathematics sort of an objective feature of the world, it's really inextricable from at least our kind of modern physics. I mean, there are people that think that the quantum wave function is a real thing in some sense, maybe only the most fundamental thing on some views. I'm not sure I can make a whole lot of sense of that. Where are you saying some mathematical thing is like the fundamental physical thing? And it seemed a bit strange to me, but there are people that think that things along these lines. And well, if so, do you think aliens would discover something like that? Or I don't know. I mean, what do you think?
it's tempting. And, as a physicist, you have this experience where you're learning about the nature of physics and you're awed by its power. Like the fact that we can predict, electric dipole moment and the muon dipole moment to so many digits, and then we can go out and calculate it and the things agree. It's like, wow, it's incredible. And it makes you feel like, yeah, this isn't just some description of the universe. We have like unearthed the source code, right? We're talking about the reality. These are the rules that the universe runs on, right? You have that sense when you discover how powerful it is. And when you look at the history of physics, there are all these moments when mathematics itself leads you to discovery. Like Maxwell looking at the symmetry between the electric and magnetic fields and discovering, why there's a piece missing here. If there was another piece here, this would be much more symmetrical, right? Just appealing to mathematical symmetry and beauty. He discovers displacement current, right? He goes out in the universe and discovers, this is real. It's not just mathematical symmetry. But the consequences of that, I think, are extraordinary. It tells you that, like, mathematics is a guide to discovering physics. And that's a really powerful argument. And that's, I think, the reason that most physicists feel, they are scientific realists, essentially, that there's a single set of laws that are out there and we are discovering them. The universe runs on something. We don't know what the source code is, but it runs on something and we are revealing it. And I think that's pretty powerful, and it's hard to argue against it. And, Hartree-Field's argument is a good one, and the axioms of mathematics being fuzzy is a good one. If I had to come down to it, I would guess that aliens are mathematical. But, I think it's worth pointing out that there are questions there. There are assumptions that we are still making.
Yeah, this is really something that could be explored in a lot of depth. Of course, people have discussed this sort of thing for many years. But
yeah.
I did want to sort of ask, like, I don't know, when we think about our physics, a lot of it is, you have your ontology, what sort of things you're positing on the theory, be it particles or fields and so on. And then you have some sort of dynamics and the various properties that things have. Mm-hmm. And that's something pretty common to the way our physical theories have worked. But how much of that is sort of human-centric? Could it be that the way aliens approach physics is radically different than that? And maybe if they do, is it like equivalent, or could you have a translation, or is it just different ways of getting at the same reality? Yeah. There's a lot of questions I could ask here, but what do you think?
Yeah, it's a great question. And, I have the experience of getting a lot of alternative theories of physics in my inbox. Not only because I'm a physics professor, but because I welcome it. I tell people, write to me, send me your ideas. I'm happy to talk about them. And I'm amazed at two things. One is how many times people reinvent the same thing. The same ideas are out there over and over and over again, which is amazing. But also there's a real breadth there. There are people out there who have come at the problem with very different concepts. And often I am able to make that kind of equivalence. I'm able to say, like, okay, well, what you're doing is really the same as this, and that has these issues, and that's why. So it's been considered before, and it doesn't work. But occasionally you find somebody with a really new idea and a new way of thinking about things. And I love seeing that because it's refreshing. Often it has its own problems and whatever, which is the reason why we haven't discovered quantum gravity by some retired electrical engineer. But it just tells you that academia is, in the current concept of physics, it definitely has gone down a certain path, and it's possible we could have gone down the wrong path, and there are other paths that are more fruitful. And I think it's fascinating to think about the concept of non-unique theories. This is something that really I wrestle with. The idea that we could have an explanation for physics that is effective, that works, and that aliens or somebody else could have another theory that also works, but that tells a different story about what's going on behind the scenes, the invisible part, the unobserved part. If there's like really just a different explanation, that's mind-boggling. And, we're familiar with examples of that, like with Newton and Einstein, where you take Newton and you generalize it to Einstein, but and they agree, in all sorts of circumstances that we're used to, but they're telling a fundamentally very different story of what's going on behind the scenes. Like gravity is not a force. Gravity is a force. It's a curvature of space-time or whatever. You're replacing your whole conceptual mechanism with something else. And so, I don't know, I don't know what the argument is to say that it must be unique. But it's also terrifying to imagine that we could have a theory that describes everything down to quantum gravity or beyond. And yet aliens could show up with their other theory and it could be different. And then we'd be like, well, then what's true? What's real? Maybe nothing. I don't have a great argument against that, which is the reason why it's sort of scary and fascinating.
Yeah. I do want to also ask, like, I don't know, it could be that our physics has some maybe arbitrary conventions in it. I mean, people talk about sign conventions and the way we'd find like things like gravity and charge and so on. I don't know. Do you think this is a serious concern, that there's maybe a lot of conventions that we have that aliens could do differently, and if so, like, might it be difficult or even impossible to reconcile them or translate them, or what do you think about this concern?
Yeah, I mean, I think if it's down to conventions, like, we're using plus, minus, 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 and they're using minus, plus, 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 right? There are lots of places where you have to make an arbitrary choice, and you could do it another way, and most people do it one way, and there's arguments. But there also could be places where all of physics has chosen one thing, and we can't even really imagine the other one, but it's equivalent and it also works. I don't think that would be too hard. I think that would be fun and it'd be exciting to see other avenues. But up to that point, it would be something within our conceptual structure of physics. And so I think that's something we could handle without too much work. I think much more difficult would be if it's at the very, very foundations. We are starting, as you say, from our ontologies, like you start from fields and you work from there, or you start from strings and you work from there. If they have a different fundamental basis, and they work from there and they have different dynamics or whatever, and yet they can predict the same experiments, then like and you can't find some sort of mapping from one to the other where you can say like, oh, okay, our fields are actually the same as your Schmields, or they're rotated or something. If you can't find the conceptual mapping, then you're left with a really hard question of like, well, what's really happening? Is it fields? Is it Schmields? Is it something else entirely? Yeah, I just don't know, but I'm excited to find out, when the aliens show up. I definitely want to talk to them about it.
Right. And to what degree do you think, thinking about the ways other life could have evolved, or maybe is more likely to have developed, bears on this? And also, well, it could be that when we speak of aliens, typically we're thinking of something like a kind of biological life, but if there's some life that's created robots or other sorts of intelligences, maybe the things that are doing these things we might communicate with are more likely to be those things rather than biological life, and that could bear on significantly as well. So yeah, I mean, how do you think about some of these issues?
Yeah, there's a couple different things to think about there. Like, one is biologically in terms of like our capacity, right? We have this incredible capacity for mathematics, which is bizarre, right? Like, we didn't need to be able to think about 11-dimensional manifolds to be able to survive on the savannah a million years ago or whatever. So it's kind of amazing that we can. And yet it doesn't imply that we have an infinite capacity, right? It's certainly possible that there are things out there we couldn't understand. And we've already seen like the power of human plus AI augmented, calculations and workflow and whatever. And so, yeah, it's possible that aliens have a different set of biological limitations. And so they've gone down a different path because they can't think about geometry, but they're super good at, some other branch of mathematics. And maybe we could find some equivalents the way we like showed that algebra and geometry are effectively the same thing, just different ways to approach the same problem, but maybe not. And I think you're right that, I don't know, it seems sort of culturally narrow to imagine that everybody's doing what we are doing, but it also seems sort of inevitable that a technological civilization is going to build an artificial intelligence and use it to augment their exploration. And I don't believe LMs are the future of scientific exploration, but I do think it's possible for AI to do science, not as we are imagining or implementing it today, but at some point in the future. So yeah, I think one outcome of this meeting could be human AI talking to alien AI, having a great conversation, And, us meat puppets are sort of like, hey, tell us what you guys are doing. They were sort of left in the dust. It's certainly a possibility. And it might be that they want to explain it to us, but it's just not something we could ever grok, That to me is maybe the saddest possible outcome, that the universe could be understandable, just not by us. That even a patient, knowledgeable explainer might not be able to get it into our heads how the universe works on a fundamental level, because it could just be beyond us, right? It's sad to imagine, but there's no guarantee that we can conceptualize the fundamental workings of the universe.
Right. Yeah. And you discuss how there's certain things that are at least currently beyond our understanding. Like we talk about dark energy, dark matter, maybe things at or before the Big Bang, if there was such a thing, and so on. And maybe to other civilizations, these things come much more naturally, or they have the right sort of tools or senses or proclivities to understand these things.
Yeah.
You talk about, in a way, the way we investigate is highly dependent on the sort of senses and perceptions we have, the scale at which we observe things and carve things up. And those are human-centric things that might not be shared by, or at least not fully shared by other civilizations. So it's another sort of thing to consider there, I suppose.
Yeah, exactly. And something that really worries me there is not just we could have different senses and we could experience the universe on a different scale, but that the sorts of explanations we accept are the ones that are intuitive to us. Like, I see this all the time teaching physics. So you explain something to somebody and they get it, they're like, okay, and they don't ask any more questions. And that's because you found it acceptable. It makes sense to you in a way that is intuitive. But to us, making sense of the universe means translating it into that language of intuition, which is dominated by the kind of senses that we have. Like, people always want to imagine like a picture of what's going on around the hydrogen atom, or what is an electron doing? Tell me what's really happening. And they want that picture because they're used to the answer to questions about what's happening is an image. Right, a visual, a geometric explanation for where things have a position and a location and a velocity and stuff. And that's because we're used to getting that. That's part of our intuitions, our visual, we're dominated by our visual set of senses, building a model of the world. And so that defines the kind of thing we find intuitive. And so aliens with different senses might not just interact with a different part of the world. They might have a different way of thinking. What it's like to be an alien could be so alien that the explanations they find intuitive, we're like, no, I still need more. I need a visual explanation. Whereas they're like, well, explain it to you in a way that's totally intuitive, but it's only intuitive in their set of senses, which determine what it's like to be an alien and therefore what it's like to be intuitive. So in the natural language of intuition, I think is closely connected to the set of perceptions we have, the senses we use to interact with the universe and the model of that universe we build in our brain. And so, what are aliens going to find intuitive? And is it going to line up with what we find intuitive? I think that's very unlikely.
And the way they do physics could also vary in another way. So, like, for example, they could be more of the shut up and calculate school of doing physics. Yeah.
No, I hope not. We got plenty of those already on Earth. We don't need any more.
Yeah. But it's not sort of hard to imagine, though, if they're just focused on, prediction and, minimizing surprise and just being able to develop the technology. If they can predict what's going to happen, then maybe they don't need to have a developed sort of fundamental theory or ontology or anything like that. I suppose it's not just another thing worth.
Well, I hope if they're listening that they don't pay attention to you, because I want them to be working on it, because I got questions about how the universe works that I'm ready to ask the aliens when they arrive.
Of course.
Assuming they don't just zap us from orbit or enslave us to send us to work in the hydrogen mines or something.
Right. Yeah. Well, that's the other thing. I mean, do you think a friendly contact is more likely than unfriendly one?
I read a lot of science fiction, and so I've thought about a lot of different scenarios. And to make science fiction interesting, there has to be a conflict. And so usually when the aliens show up, they want something. But if you think about it, like, what do we have anyway that they would want? Like water? There's like planets of water in the solar system. Help yourself. Hydrogen, like take Jupiter. We don't care. Like there's not much on Earth that's special except for us. We are the thing that's unusual in the solar system. And so I do think that if they come to Earth and they want something, that something is going to be to talk to us and to understand what we're doing and what we've learned and who we are. Otherwise, they just wouldn't care. And why would they even bother to stop by? I don't think we have much else to offer. Everything else we have is more easily found elsewhere in the universe. So that's my optimistic view of meeting aliens.
Yeah, fair enough. And just thinking about some of the arbitrariness or anthropocentric biases in terms of how we carve things up. Like I was thinking maybe, okay, of course there's some, or maybe a lot of arbitrariness and human bias in how we carve up things like, planets and people and trees and whatever else in our environment. But maybe it's less likely to be so specific for the things that show up in physical theories. Maybe for like, if we're talking about particles or fields, it's like, well, it's more likely that the sort of theories that develop would have those things as ontological posits, rather than, even some of the other stuff you discussed, like eddies or whatever. I don't know. What do you think about that possibility?
I'd like to believe that, but if you ask 10 particle physicists, what is a particle, you get 10 answers. So there are some of these concepts that we have that are historical, that we have names for, that we attach some ideas to, that we don't even really have a consensus for what we're all talking about. And so I think there's a lot of room there for like human arbitrariness. And, zoom out from particles and think about planets. Like, man, just listen to the astronomers argue about what's a planet. They're obviously bending over backwards to try to reverse engineer some category where we're important, where like the thing we're living on is rare and special and interesting. And most of the reasonable definitions they come up with, you end up with either no planets or like 1,000 planets. And so they don't like those. So they add like, it's got to be a minimum size, or they add all these like ridiculous worthy cues on it to engineer this category. So that category is not like arbitrary. That category is totally arbitrary. It's not like universal. And if you're an alien that grows up on a moon or in the atmosphere of a solar system, you're not going to look at a solar system the same way. Look at our depictions of the solar system, right? The planets are always like massively overrepresented. Even like on the Pioneer plaque, like there's the sun and the earth. I'm like, okay, yeah, the sun is bigger, but not to scale, right? Planets are never shown to scale. They're always blown way out of proportions. And so there's a lot of humanity in picking, as you say, like the elements, right? The ontology. What are the things we're talking about? Choosing those to start from. Even those choices we make, I think, are potentially have a lot of culture in them. And it touches on another great debate in philosophy, which is this question of emergence. Why is it even possible to have Kepler's laws, to apply Newtonian physics to 10 to the 26 quantum particles, and to mostly get the answer right? Why is that even possible? Why can you make chicken soup without knowing quantum gravity? And nobody knows the answer to that, right? Why does simplicity emerge from the chaos? And because nobody knows the answer to that, it might be that it's not emerging, that it's like we're filtering it out, that it's the way our brain is representing this incredible buzzing cosmos, and that aliens could see it differently. And so I think, a lot of these questions don't have answers because they're deep questions in philosophy. And so, I'll punt it back to you guys and say, hey, you guys should figure out the answers to some of these deep questions because they might be important for when the aliens arrive.
Yeah, I like that a lot, actually. So, I guess one of the main lessons you draw about in this book is, well, maybe this is going to reveal more about ourselves and our history and our practices and so on.
Mm-hmm.
Then it might we can speculate about what aliens might be like, but I think it does a great job of highlighting some of these contingent historical and psychological and just features about what we've done.
Yeah. But it's just like when you go traveling, yes, you learn about weird breakfasts they have in other countries, but also you learn about yourself. You're like, oh, I never imagined you could eat something else for breakfast, or that people could pee in doing this instead of doing that, or like, you learn a lot about your own blinders and your culture, and that's why it's wonderful. And so that's why I say, like, when the aliens arrive, I kind of hope that they don't do physics the way we do, because we learn so much about the choices we've made and what it is to be human in the universe. And in the end, like, what's philosophy about, right? It's that. It's about what is it like to be human and why is it like that? So yeah, when the aliens arrive, maybe we should get two kinds of aliens, right? One that are just like doing physics the way we have and can zoom us forward in the future, and another kind that are like, no, y'all are on the wrong track, and the universe is totally different, and you're even asking the wrong questions.
Right. Yeah, I mean, what other ways forward do you see for this sort of these sorts of questions? Like, okay, part of it is trying to tackle these kind of more philosophical questions. What else do you see? I mean, doing more physics. I mean, I don't know.
I think we need a deeper dialogue between physics and philosophy. I mean, there's people in philosophy asking these questions, and philosophy of physics have been asking these questions, but physics itself is sort of walled off from that. And I think there's the possibility that, if we have a closer dialogue, we can realize, oh, there are some unexamined paths here. There are some places we've made arbitrary choices. So let's go dig into those from a physics point of view. Let's see if we can make progress. Let's make a different choice and try to make progress. Let's be our own aliens, essentially. I think it could really help physics to understand where we've made, human choices that are cultural. And I think that in many ways we're behind biology. Like, biology's already done this work. They've understood, okay, carbon is the backbone of all life on Earth, but they've thought about maybe it doesn't have to be. And that's inspired their search for silicon-based life here on Earth. And it's going to help us look for alien life. When we land probes on Titan, for example, we're not just looking for life on Earth, because we're open to other kinds of life, because the biologists have done that work. And so I think we need to do that kind of work, the physics community, and it'll help us expand physics, and it'll help us be better prepared for when the aliens do show up.
Yeah. And for actual current scientific practice, do you think that thinking about some of these things can, rightly make us more skeptical or concerned, or like want to double check some of the assumptions or things that go into actual just current science? I mean, like, do you think you could have that effect?
Yeah, I think so. And I want to be careful here, because there is fair criticism of academic physics to say, look, you guys have chosen some path and there are other paths. I think that's fair. There's also this like science populist, there's a crisis in physics and academic physics is dominated by bad faith idiots who are, wasting everybody's time. And I don't think that's well-founded at all. It's not the community I recognize at all. I think everybody here is doing their best to be curious and try to understand the universe. But I do think that it's a bunch of people, and people operate in a certain way. And we should have more diversity of the program. We should quintuple the theoretical physics, funding, so that we have room for more people doing more investigations in lots of new different directions that could definitely inform our understanding of the universe. Absolutely. So I think there's a lot more room for diversity of approach in fundamental physics, and we should have more people doing it. Totally agree with everybody on that one. I think that would be very helpful.
Yeah, very good. I like one of the things you said there, I don't know. I'm watching people like Eric Weinstein or Sabine Hossefelder complain about some of these things. Maybe some of their concerns are legitimate, but I mean, a lot of it is, I think, overblown. And that discussion with Sean Carroll and Eric was pretty funny, but
how dare you?
Exactly.
Yeah, I mean, that's a clown show, and obviously, I thought Sean did a great job of handling that and taking it seriously and being respectful, honestly. But I do think, again, that there are ways we can improve academic physics. I think mostly it's just down to limited funds. I mean, I think if Sabina feels like her grants weren't funded and they were, good ideas, I think that's a familiar experience. Lots of people have good ideas. They throw at the funding agencies and they hear no. It doesn't mean that the funding agencies are biased or that, they're being dominated by people who are submitting bad faith ideas. It just means there isn't enough money for all the good ideas that they get. And so we should have more money. I don't understand why we don't spend more of our capital on basic research, including philosophy, and fundamental physics, because it pays for itself so big. It's such an excellent return on investment. But I don't know. I'm not a politician. I don't understand the way these things work.
Yeah, I agree. And it's tough because I think a lot of people look at it, politicians look at it and say, well, but they don't know ahead of time necessarily how it's going to pay off or whether it will pay off. But historically, it tends to, right?
Always does. Yeah. Huge. Yeah. Think about the physics research that went into the discovery of the transistor. That has led to trillions in economic development. Just that one investment, I think, even if nothing else in physics had ever led to anything, and obviously it has, that one investment would bring it into the black. So anyway, yeah, I agree with you, but I don't understand why we don't spend more money on this basic stuff. It's the goose that lays the golden egg.
Or it's maybe one of the biggest ones is the return on the moon landings. I mean, not just from the technologies that's developed in order to facilitate those, but just the cultural impact and all the stuff that came out after that because of that. I mean, it's just huge. Mm-hmm. But yeah, I still wonder how might things have been different if they had approved that particle accelerator in the United States. But
oh, that's a whole alternate universe I'm always curious about. Yeah.
But great. So I do normally end with a kind of general, usually more metaphilosophical question about the value of philosophy. But I suppose I'll ask it more about the value of this, intersection of philosophy and physics, although maybe this has already been answered in the course of the discussion. But I don't know. What do you think is some of the value of approaching these issues, especially at the boundary of or intersection of these philosophical and physics questions here?
Yeah, well, number one, I think it's really fun. I love thinking about what aliens might be like and fantasizing about what it's like to talk to them. And so if you find it fun thinking about aliens and what they might be doing and how they might think, then I think you would totally enjoy the book. What's the value in it otherwise? I think, as I said earlier, it's going to help us identify places where we have made arbitrary choices, things defined by our history, the particular path that we took through physics. And, another thought experiment is the one you just mentioned is what if our science had gone a different way? Well, you don't even have to go to aliens. What if you ran the Earth experiment 1,000 times? How many times would you get a collider in Texas or not? Or how many times would we have completely different physics because of some other detail, or Aristotle didn't exist, or somebody smarter did earlier or something? It's fun to imagine, and it makes you realize how sensitive our current framework and way of thinking is to a bunch of historical accidents. And so I think it's valuable to realize how much arbitrariness there is in things that we typically treat as fundamental, as universal, as the foundational truth of the universe. And I think there's real value in sort of waking up the physics community to this a little bit. My sort of fantasy is that the physics community, is a little bit offended by the concept that aliens could do physics differently, but that then they read the book and they're like, okay, yeah, I see what you're saying. Maybe that's true. And then we use that to build a deeper conversation between physics and philosophy. I mean, I feel like most physicists have strong philosophical opinions, but also think philosophy is a fool's errand. And so at least I want to wake up people to realizing that they're doing philosophy, even if they don't realize it.
So that's a great way to put it. So yeah, I think didn't have much more. Now we could draw the questions to a close there, and I'll provide a time of recording. The book is, I think, still only available for pre-order, but I think it comes out early November. And I'll include links to where people can find it. I definitely recommend people check it out. It's a really fun read and fascinating stuff. So yeah, thanks so much for coming on, Professor Whiteson, and taking my questions. And yeah, it's been great. It's been great having you.
Yeah, thanks very much for the conversation. Super fun. And please do check out the book, Do Aliens Speak Physics?